guys, welcome back to my YouTube channel. Today we are going to solve day 19 problem on LeetCode. And if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. So today is Monday, and that's the reason I think on weekdays, especially Monday, they give easy problem. So now let's try to solve this problem, power of 2. Okay, so in this problem I am going to solve this in total 3 ways. Okay, and in the end I am going to give you a solution with just O of 1 time complexity. Okay, so in the end I am going to write just one line code to solve this problem in just one O of 1 time complexity. But before that let's solve it using the beginners approach. Okay, if there is any newbie, so I'm going to tell how it is how they are going to solve it. Okay, so most basic way of to solve this problem. So in this problem we have given an integer n and we have to return true if it is a power of 2, and otherwise we have to return false. Okay, and integer n is a power of 2 if there exists an integer x such that n is equal to 2 raised to power x. Okay, so here for beginners, what they are going to do, they are going to run just one for loop for int I is equal to starting from 0, and after that they are going to use a math.power function. Okay, so 2 raised to power I. Okay, so here 2 comma I, and it should run till it is less than n and I plus plus. Okay, so here in this particular approach time complexity is going to be O of log n. Okay, because we are running from the 2's power I. Okay, we are running this loop like that. So inside that they are going to check if math dot power okay 2 comma I, if it becomes is equal to n. Okay, if it becomes is equal to n, then in that case they are going to return true, and in the end they are just going to return false. Okay, return false. Okay, so in total this for loop is going to run how many times for this specific problem? Let's say n is equal to 16. Okay, so first time n is equal to 16 given to us. Okay, so first time when I is equal to 0, so it is going to check if 2 powers 0, that is 1, is less than equal to 16. After that, when my I becomes 1, then it is going to check if 2 power 1, that is 2, is less than equal to 16, so 2 times. Then after that when my I becomes 2, then it is going till math dot power, that is 4, 2 power 2, 4 is less than equal to 16, and after that 2 power 3, that is 8, is less than equal to 16. Then after that 16 less than equal to 16 when my I becomes 4. Okay, so when my I becomes 2 power 4, that is 16, is less than. So in total here you see 2 powers and my loop is going to run. So that is the time, that is why the time complexity is going to be of log n. Okay, of log n is the time complexity for this problem. So now let me run it. Okay, so I hope that you guys are clear. So let me run it and see if this solution is acceptable or not. So let me submit it. So our solution is accepted, and see here it is runtime is 1 millisecond. Okay, but still we didn't beat more than 50% of users with Java. It's still 49.23. okay, so this is one way to solve this problem, and there is one more way, more beginners friendly way in which what they do, they are just going to check. This solution is also going to run in O log n, but it's just another way to write this code without using math.power function. Okay, so here they are going to check if our n is less than equal to 0. In that case we have to just simply return false, because 2's power negative number is not will give anything. Okay, so here this is given that if there is any negative number, then the 2's power we don't get that number. Okay, so let's say here it is -1, so 2's power 0 is going to be 1 only, so we don't get any negative value if we raise it to 2p power. Okay, so here if our n is less than equal to 0, then in that case we have to just simply return false. And if my n becomes 1, if my n becomes 1, then in that case we have to just return true, because 2's power 0 is 1. 2's power 0 is 1. Okay, and one more thing that I'm going to check, if there is any odd number, then definitely when I'm going to divide that number with 2, okay, so modulus will not be equal to modulus will be equal to 1 if there is a odd number. Okay, so let's say n is equal to 17, so 17 mod 2 will give the remainder 1, right? So odd number always give a remainder as 1, so in that case also we have to return false. And in the end I am going to call this function recursively, return this main function is power of 2, and in the next step is power of 2. And now next time I am going to pass this number as n divided by 2. Okay, so now let's run it. So first time n is 16, after that I'm going to check for n is equal to 8, after that I'm going to check for n is equal to 4, after that I'm going to check for n is equal to 2, after that I'm going to check for n is equal to 1. So when my n becomes 1, then in that case I'm going to return true. So same way here also time complexity is of log n. So now let me run it. Let's submit it. So now it is showing 1 milliseconds runtime, and it beats just 49.23% of users with Java. Using bitwise approach I'm going to explain now. So let's say one thing before solving this problem using bitwise operation, let's say this is how we write operations in bitwise. 1, 2, 4, 8 bits. So I'm going to convert any number into bits right now, 1632. Okay, so when my number is 2's power 0, then how I'm going to write that number? I'm going to write that number like this, right, in bits. Okay, if my number is 2's power 1, then I'm going to write that number in like this, 0 0 0. Okay, in bits, single bit is set here. When my number is 2's power 2, then I'm going to write that number like this, 1 0 0 0 0 0. When my number is 2's power 3, then I'm going to write that number like this in bits. Okay, here I'm going to show you one thing. Okay, so just focus. So when my number is 2 raised to power 4, then I'm going to write like this. Okay, so here in all the numbers you can see only one bit is set. Only one, there is only one bit that is set. So here 1 is at this place, here 1 is at this place, and all the numbers are 0. Here 1 is at this place and all the other numbers are 0. Here 1 is at this place and all the numbers are 0. Here this 1 is set at this place and all the numbers are 0. So any number which we can get with the 2's power. Okay, so for all those numbers only one bit is set. Okay, and what happens if let's say my number is 16? So this is nothing but 16 only, right? This is 8, this is 4, this is 2, this is 1. What happens if I subtract 1 from these particular numbers? Okay, so if I subtract 1 from this particular number, so now this is 16, it becomes 15 when I subtract 1 from it. Okay, so how can I represent 15 in using bits? So I can represent 15 like this. See, 1 second, let me pick this one. Okay, so 15 I'm going to represent it like this, 1 1 1 0 0. Okay, this is 1 2 3, total 1 plus 2 is equal to 3, 3 plus 4 is equal to 7, 7 plus 8 is equal to 15. So when I set number as 15, that is, this was 16, now I subtract one number, so it becomes 15. After 15, using bits, I am representing this number like this. Okay, so here one thing you can see here, this is 16. Okay, this is 16 and this is 15. Okay, so one thing that you can see here, all the bits after this particular bit are flipped, right? So all these bits are 0. Now all these bits become 1 and this particular bit becomes 0. Okay, when I subtract a number from minus, when I subtract 1 from this 16. Okay, so let's take one more example here. So let's say this is a number 4 is given, this is 4. Okay, this is 4. Now I subtract 1 from this 4, so now my new number becomes 3. So how can I represent this 3 in bits? So I have to just flip these two bits after this particular set bit and make this bit 0 and all other bits will be 0 only. Okay, so here see this, so these two bits are flipped and this bit becomes 0. Okay, so this is how I am going to represent 4 3. So here let me write it again. So 4 4 numbers are like this. Here let me write 1 2 4 8 and 16. Okay, numbers are like this, 4 4 0 0 1 0 0. Okay, when I subtract 1 from 4, then the numbers becomes like this, 0 0 0, and all the bits after this set bit becomes 1. Okay, so this is how my 4 3 looks like. Okay, one more thing, when my number is 16, then it is like this, using bits 1 0 0 0. Okay, but when I subtract 1 from this 16, then it looks like this number, all the bits after this set bit becomes 1. Okay, this is how we represent 15 in bits. Okay, so here this is clear, right? This is clear. Now when I use AND operation between these two numbers, then what is the result? Result is going to be 0 1 0 0 1 0 1 0 0 0 0. Okay, and here also result is going to be 0 0 0 0 0. Okay, for both the bits should be set to 1. In that case only we get 1, otherwise we get 0. Okay, same number. Okay, so here this is clear. So now whenever any number is in power of 2, so we will get output as 0 only after performing the bitwise AND operation between that particular number and one less and minus 1 that number. Okay, so here I'm going to write the code, so just one line. Okay, so for negative numbers we know that 2's power will not give any result, so here I'm going to just simply return. Okay, if my n is less than is greater than, return n is number should be greater than 0. One thing is clear. Okay, number should be greater than 0, only in that case power of 2 is possible. Okay, and operation, and inside that n number, the particular number, let's say 16, and bitwise and between this particular number and n minus 1. Okay, n minus 1. If these two conditions, okay, so first this one, it should be equal to 0 only. Okay, so this condition should be equal to 0 only, and let's say this is 16 and 15. Okay, 16 and 15, it should be equal to 0 and our number should be greater than 0. So let me run it, let's see. Okay, so all the test cases has been passed. Now let me submit it. So our solution is accepted and it beats 100% of users with Java, right? So I hope that you guys are able to understand this particular problem using bitwise operation, and in this case complexity of 1. Okay, in just one complexity. Okay, of 1 complexity. So if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Thank you. Meet you in the next video. Bye bye.